We're going to continue our discussions on class relationships, and we're going to talk about 5 different types of relationships and how different classes might relate to one another. So if you haven't already, go ahead and open up the worksheet that goes with this, and as you go through this video, fill out the chart. So number one, you have a quick reference so you don't have to search through the video over and over again. And number two, this is what you're going to submit as our no-brainer for this particular chapter, is this file. All right, so let's talk about the first one. We're just going to go in order. Inheritance. You might have two objects, and the two objects relate in a way that, so here's our example. A car is our first object, and then we might have a sedan. Well, a sedan is a type of car, so that is a type of relationship. We also might have an SUV. An SUV is a type of car. This is an inheritance relationship. Now, with inheritance, you have a parent class and a child class. It also might be called a superclass and subclass. It could be called a base class and derived class. Those are different names that mean the same thing of inheritance and which part of the inheritance you are. Personally, I like parent and child because I know that a child is derived from a parent, and it's just kind of makes sense. But you also might see the others with different instructors, different textbooks. They all mean the same thing. Now, this is unidirectional. A child comes from a parent, and the child can only send messages to the parent. The parent can't send messages to the child. Example of this is, this is what the code looks like. You would have your class, and that's your parent, and then you have your derived class, your child class, and then there's a colon right next to it, and then there's the keyword public, and then whatever your superclass is. So if we have a class animal, you can have whatever code you want in there, but then we're going to have a dog class. So I've got class dog colon public animal, and all this is saying is dog is using all of the code of the parent class, but it has some more code that is specific to a dog. And it's a nice thing about inheritance. Inheritance is the one you're going to use most often, and the reason why is because rather than repeating code in multiple classes, you can just have several classes that use the same base code and just have their own little details added to it. Okay, association. Association, not used as often, but you will see it. It's loosely based on each other. So there's a class, and it has this, and this has this as well. So a contractor has a project, but a project also has a contractor. So the two need to interact with each other, and they need to have all of the details. It's not one direction like an inheritance. So here is how an association code pattern would be. You would have your peer, your class peer 1, and a class peer 2. Peer 1 would have a pointer to peer 2, and peer 2 would have a pointer to peer 1. So if peer 1 changes any of the details about it, since it's a pointer in peer 2, you would automatically have updates to whatever changes happened to your peer's class. Okay, so code pattern. This is the next section. Make sure you get this down on your diagram. Okay, now this is what the representation, the UML, looks like. You have a black arrow pointing in both directions. So this object has a black arrow pointing here. This object has a black arrow pointing here. Okay, the next kind of code association there is called aggregation. Now, aggregation means that how to explain this one? All right, so here you have a car, and a motor is part of a car, and a motor is not a car. just like it, so it's not an inheritance type of relationship, but the car has a motor. Now the thing about a motor is it functions independently by itself. Like you might have part of the motor that breaks down, but the car is still in pristine condition. It just doesn't drive because the motor doesn't work. So it's part of each other. And I say that because we're going to find other places where you might have a has-is relationship with a different code pattern. So your syntax, this is your UML, is going to have this little, what shape is that? Little diamond shape with a line connecting to the two. And it's connecting on the side of the whole. So here would be your motor connected to your entire car up here. What that looks like, it's kind of like it's very similar. It has a part and it has a class whole, but your part is just a pointer to the class part, meaning the class part can function independently of the whole. And the one that's confusing is the next one, because aggregation, oh, here's our abstract representation. I'll show you that in a sec. So the abstract representation is you still have a line, but it's only one line pointing to the other one right here. The whole is going to point to the part. Okay, now composition is another has-of relationship. It's exactly the same as aggregation, only it's the little diamond is filled in. So you have a whole and you have a part. Okay, now the difference is the whole doesn't share its parts with other objects. So you can still have the same example, a motor is part of a car, but in this case, if the car dies, we're going to scrap the motor. Whereas if the car dies with aggregation, we're going to pull that motor out and put it in another car. So it kind of depends on whether you need the part to function independently, or do you need the part to just function as part of the whole? That would be composition. If it needs to function independently, it would be, let's see, let me give you a good example, because these two really confuse me too, because they're super similar. Take a Tetris game. A Tetris, we have those little blocks, right? And there's 4 little blocks that form up of a shape. Well, each of those blocks need to function independently, because when they hit the bottom, they're going to be part of the entire grid. They're not their own shape anymore. They might disappear if someone fills up part of the row. So that would be an aggregation situation where you have a part that functions as a whole. Versus, what's another has-is? I can't think of a good composition example right on the fly. Sorry about that. How about a dog? Suppose we have a class dog. Well, a dog has a tail, and the dog has paws, and a dog has, all these different parts to make our dog. But without that dog, those parts do not exist. And so that's kind of an example of composition and the difference between composition and aggregation. Okay, composition code pattern, you have some sort of part, and within your class, within your whole, you have another part. So it's just an instance of the class. It's not a pointer because it doesn't have to function independently outside of the class. Here's our abstract representation. Here's your whole, and you have a part as part of the whole. Doesn't have to share. Sharing, you don't have to share the part with any other object. That's a key thing to composition. Dependency. Okay, so you might have just a loose dependency on another thing. Calculator depends on a fraction. Calculator uses a fraction. Calculator delegates to a fraction. Just a loose relationship. It's not part of it. And you represent that with a dotted line and an arrow. So here we have a dependent client user and an independent server supplier. And it's just loosely based on one another. And the way we know this is the class doesn't even have any of the objects instantiated in it. You just might have a method that uses it. And it might send an instance of the object, it might send a pointer, it might pass by reference, but you're just using another class within your class, but it's not really part of your class. Okay, if you missed any of those, here is the whole chart all in one that you can get them down. I probably should have put this first, but then you wouldn't have listened to the lecture, right? No, I'm sure you would have anyway. Okay, so that is it for our no-brainer today. Oh, we do have a little bit more. Function overloading. I want to show you one last example, and that's the use of virtual functions. I'm going to show you this example. I have this example here on my presentation, but I want to show you this example instead. Okay, so in this situation, I've got an inheritance situation. I've got a base class, I've got a derived class, and I can't remember why I put a second derived class in there, but with no code in it whatsoever. I mean, look at that. Okay, now with this base class and derived class, I've got my derived 1, and then I've got a pointer to my derived 1. My pointer is set equal to the address of my derived 1. Same thing with my derived 2 for some reason. We'll get to that in a sec. If I run this, even though if I were to do, where is it? My pointer dot show, it's showing the cout statement in the base class. And if I were to do it for just my derived 1, here I say d1 dot show. Remember, back to our pointer situation, I can use a dot here because it's not a pointer. Even though my pointer is pointing there, it's still showing the base class. My original class is showing this derived. Okay, now I'm going to show you what a virtual function is. All you do is change the base class to make that show be a virtual method. And in this situation, get rid of a couple of these cout statements so you can see. This means that this function is determined which one is going to show, this show or this show, but it's going to determine that at runtime instead of at compile time. So in this situation, now that we've set our base pointer, even though our pointer is a base, but since we're setting it equal to a derived object, it should now show our derived class. I'm going to hit run. So you can see that it's showing our derived class, and that's because show is listed in our derived class. However, our derived 2 class doesn't have a show method, so it automatically knows to use the code from the base class. Okay, so virtual, all virtual does, and we're not going to use that much in this class. You'll use it a lot in your data structures class next, but just know that a virtual function determines which function is going to be called at runtime instead of at compile time, which is a normal function looks like. Okay, I think that is it. Early binding, because all I do is add this into the show. Yeah, okay, that is it. Submit this as your no-brainer, and we will see you in class and have some more practice with different class relationship types.